In this video, I'm going to go over linear functions, specifically to do with lines. Now, we all know the equation of a line, y equals mx plus b, right? M is whatever constant and b is whatever constant. But y is your output and x is your input. X being the x-axis, y being the y-axis, the vertical axis. Now, function form, we put f of x equals mx plus b. Same thing. It's always going to be mx plus b. F of x is just a fancy notation. F is for fancy. All right, so let's do an example. Kind of a real-life example. We're going to not be quite accurate with it because we're not changing anything. Well, I suppose we are changing something. But anyways, let's have a function here of distance in terms of time. Okay, so we have time in seconds. Okay, and distance in meters. And we have a car going down the highway at 28 meters per second. Got it? If you convert that into miles per hour, you should get about, 62 miles an hour? Maybe 63. So that's about normal for the highway, right? Anyways, let's just assume that we're keeping that speed constant and that we were already at that speed when we started our timer, right? Sometimes you forget to reset your odometer before a long road trip, or maybe we just crossed a state border or something, and we just want to keep track of the distance what we've gone since we crossed that border. All right. So what does that mean? That at 0 seconds, we were at 0 meters. That's what I'm trying to say about that. Okay. Anyways, what is happening here? We travel 1 second, we go 28 meters, right? Travel another second, right? We went 28 meters again. That's all that means. So if we go 28 meters every time, what is our equation? What is our function? If we were to write it out in mx plus b form, what would it be? (28t). That's it. Not too difficult. Just remember that t is your variable. And, 1 times 28, 28, 2 times 28, 56. It fits, but how do we know that? Because 28 is our slope, right? M is the slope. That is our rate. That is our speed, if you will, 28 meters per second. So if we start at 0, right, 0, 0, then we start at the origin. Let's graph this. So second point is 128. Okay, let's guesstimate where the 28 is, right about there. 256, okay, all the way up here. Let me make sure this is aligned. Okay, 384. 4, 112. And 5, 140 is off the map. So, all right. I might have accidentally drawn a little curve because I can't draw, but that is a straight line going up. My scale is not very well drawn, but if you plug this into your graphing calculator, you should get a straight line. Now, it starts at the origin because there's no such thing as negative time, right? This is the negative x direction. So our domain is what? Including 0 all the way to infinity. All right, that's the domain of our function here. What is our y-intercept? Well, 0, 0, of course. Because we did plus b, it's just b is 0, so nothing happened there, right? That's one of the easiest y-intercepts you can have. So that is a line function. What is the significance of slope? Well, looking at the slope, it tells us how much distance we gain with every passing second, obviously. However, it also, every part of the slope gives us a clue to what the graph looks like. If it's 28, if it's a high number, and we know that slope is rise over run, right? And every whole number is over 1, so the rise is much greater than the run. It means it's going to be a very steep line. That's why I have the y-axis scaled to 10 instead of 1. Because, oh man, it would be going almost straight up, right? So just by knowing that, you can picture in your head like, oh, if it's a nice whole number, it's much greater than the run, the rise is much greater than the run, then it's going to be a very steep slope. If it's positive, that means it's increasing. What do we mean by increasing? It means that we're going up as time is going on. We're going up, right? It's increasing. It's not decreasing by 28 every time. It's increasing by 28. All right. If it was negative, it would be decreasing. All right. Now, what's the other number besides positive and negative numbers that the slope could possibly be? Could be 0. Right in between positive and negative, right? And what happens if the slope is 0? Well, let me draw it real quick for you. Another crude drawing. Let me just erase this. All right. Slope is 0, then we get a flat, constant line. So it's constant, right? It would just be y, or not y, f of x equals -7. That's what this is right here. This is the x-axis up here. This is the y-axis. And this is -7. 1, 2, 3, 4, 5, 6, 7. Right? It's just constantly -7 all the way through. There's no change. There's no change, right? Because the rate of change is 0 in that case. But if it's negative, it would be going down, right? From left to right. It's not always going down because the line goes in both directions, right? So it's going up to the left, but that's the negative direction, right? When we're talking about increasing and decreasing, it's always about what's going on in the positive direction. It's that arrow pointed down or up. If it's pointed straight, then it's constant. One more thing about the y-intercept. There's only one y-intercept. Why? Because it's a function. If it's not a function, there might be more than one y-intercept, and therefore it would fail the vertical line test. So what if I just gave you any random equation and asked you to draw it real quick? If I just said y, I always start with that y. You get into function mode. F of x equals, I don't know, negative 3/5 x minus 12. How would you go about drawing that? Would you just plug in numbers for x and see what comes out? No, no need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 down. That's our y-intercept. That's where we start, right? Negative, right? So we know it's decreasing. So it goes down and to the right, and it goes up to the left. So we are rise over run, right? 1, 2, 3. We go up 3 and then over 5. 1, 2, 3, 4, 5, 7, 8, 9, 10. Okay, 1, 2, 3 again. 1, 2, 3, 4, 5. Right about there? Yeah. 1, 2, 3 again. And then over another 5. 1, 2, 5. And boom, we have 3 points. And we can pretty accurately draw that line. It's really that easy. You don't have to make a table. You just think, oh, there's my y-intercept. That's where I start. Look at my slope. Is it negative? Yes. Then it's going down to the right. Rise 3 over 5. If it was positive, it would be up 3, right 5 instead of up 3, left 5. You know what I mean? All right. Thank you for watching.